Welcome to a video on transformations of cubic functions. So you have seen this before in Module 1 and Module 2 with quadratic functions, absolute value functions, linear functions, but we are going to talk about cubics today. So we have three goals. So we're going to describe transformations, graph them, as well as write functions from them. So first off, you should be on Canvas and you should have already done the Desmos transformation activity. And so if I pull it up on Desmos, you guys played around with these sliders and saw that if you have a positive number on the outside, your k value will go up. If you have a negative number, your k value will go down. Same thing, you should have explored your h value, which is inside the parentheses, noticing some movements. Okay, so make sure you've done the Desmos activity before you get to this part of your video. But let's talk about what you learned in your activity. So the first thing, a horizontal translation, horizontal is left to right. And so if you add a number in the parentheses of a function, that's going to move it left or right. Now this is the opposite of what you think. So if I put a -5 in my parentheses, you would think it would go to the left, but it is actually going to go to the right because the opposite is happening. If you put a plus on the inside, that's actually going to move it to the left too. So that's what you saw in your Desmos activity. If you add a value number on the outside of your function, that is going to move it vertically, which means up or down. And that one is not opposite. So if I put a +1, that should move it up 1. -4 should move it down 4. Okay, so those should look familiar to quadratics. Reflection, we have not talked about this one before. We have talked about putting a negative in the front. So if you put a negative in the front, we know that flips it or reflects it over the x-axis. Now we've covered that, but this part was a little bit new. If you put a negative inside your parentheses, that's going to reflect it over the y-axis. Now, graphically, these look the exact same, and I will show you. So if I'm on Desmos, I've got my cubic function graphed in red. If I put a negative out front, that will reflect it over the x-axis. So this part moved up, this part moved down. Now if you reflect it over the y, it's going to look the exact same. This part will come over here, this part will come over here. So again, blue and green look the exact same. So that's the good part about cubics, is reflecting it over the y or x pretty much looks the same. The last thing is you can have a number in front of your function. And so we've talked about if it is bigger than 1 or if it is smaller than 1. So if it is bigger than 1, it is going to stretch vertically by a factor of 8 in this example. So stretch, think of pulling something super tall. So here's my normal cubic. If I make the number bigger than 1, it is getting taller, taller, taller. It is getting stretched vertically. If you have a number smaller than 1, but not negative, that is going to shrink it by a factor of 1/4, and that is where it gets very wide. So let me show you that. If I have a very small number, so for example, 0.2, see how my graph is very, very wide compared to my original, much wider. So that is an example of a shrink. So these are the transformations that can happen with cubics. So let's take a look at some examples. Example 1, you are going to describe the transformation of the parent function x cubed, which is f, represented by g of x, which is in blue. So basically tell me what's happening with this +5, what's happening with this +2. I can see this -5, moved it to the left 5, because it's the opposite. This +2 moved your function up 2. And so that's easy to see if you look kind of where it flattens out. This graph went to the left 5, and then it went up 2. So what you guys are going to try, you're going to try 1, 2, 3, and 4. I want you to describe the transformation. So tell me up, down, left, right, reflect, stretch, shrink, as well as sketch a rough graph. You can use your calculator if you need to for help, or you can take your best guess. So press pause and try those. All right, so here is what you should have got. The parent function f of x is graphed in red. Number 1 is going to move down 2, so your y-intercept is at a -2, and then snake it on through. Number 2, it went to the right 3 and down 3. So I went right 3, down 3, and then I've got my best cubic. Number 3, this negative is going to make it reflect over the x-axis. That 1/4 is going to vertically shrink it, aka make it very wide. So try and give me a very wide cubic, and instead of going up, it is going down. Number 4, this 2 out front is going to stretch it, make it very tall, and then this -3 will make it go down 3. So it's snaking and getting flat at a -3 and then shooting up. So very tall versus very wide. Okay, so that's how you would sketch a rough graph. Let's move on. You guys are going to try some again. I want you to try 1, 2, 3, 4, 5, and 6. On 1 through 4, you're matching with the correct answer. You cannot graph this one in the calculator because it has a f of x, but use your rules to help you. Number 5, tell me what the error is. And number 6, describe the transformation from f to g. Press pause and try these on your own. Here are your answers. So on number 1, this graph was going to the right 2, so it's still going to be on the x-axis, just over 2, which would be graph B. On number 2, it's going to go to the left 2 and up 2, and so that would be graph C, to the left 2, up 2. D is going to the right 2, because it's the opposite, and up 2. So you could have gotten C and D confused based off these signs. And on number 4, A just went down 2, which would be this graph. On number 5, the error, they actually went to the right 2 and down 6 instead of going to the left 2 and down 6. So they went to the right versus to the left. And so remember, you've got to switch that sign to a -2, which means go to the left 2. So this is what your graph should look like, evening out, flattening out at a -2, -6, and then a cubic going up. Number 6 tripped me up because I forgot that they were going by 2, not 1. So you see 2, 4, 6, 8, and so this graph went to the right 2 because you are going from F to G. So if you said right 1, you just forgot to see that they're counting by 2s. And that is transformations. So let me know if you have any questions, but that's it. So hopefully that should be a nice little review for Module 1, Module 2, and Module 3. We are going to continue with a nice little review. We have done regression for linear and quadratic, and we're going to do regression again for cubic. So if you remember, when we're doing regression, we have to use calculator, and we're going to press the stat button, edit button, and type in our table. So pull up your calculator, and let's do this. All right, so in our calculator, I'm going to press the stat button and then edit to enter in my table. Now I have already done this to save me some time, so if you have not, press pause. But type in x into L1 and f of x into L2. Once you have done that, you are going to press stat, go over to calculate, and we are on cubics, so we are doing cubic regression. So go down to 6, hit enter a million times, and this should come up on your calculator. So notice I have a cubic in standard form, so I've got A, B, C, and D, and I'm going to write the equation. So your calculator will give you decimals. Now I can turn this into a fraction because this is a repeating decimal. If you do not know what fraction that is, for example, I don't know that off the top of my head, I'm going to go to my calculator and type in 0.1666666 repeating and hit enter. And it should round it to what your calculator has. To turn that into a fraction, you're going to press math, enter, enter. So this fraction is 1/6. Same thing, if you do not remember what 0.3 repeating is, you can hit 0.333 and hit math, enter, enter, and it will turn it into a fraction for you. So my equation is going to want fractions. So I will have y equals, my a value is 1/6, and then my x cubed, plus my b value, 0.5 is a half, x squared, plus my c value, which was 1/3, x, and then I do not have d is 0, so I am done. So here is my cubic regression equation for this table. Okay, we're going to do one more on number 2. Now this one wants decimals, so that is fine. But if it is a nice repeating decimal, you can turn it into a fraction. So number 2, we're talking about the number of active bald eagle nests in Florida T years after 2000. So use cubic regression to find a model for the data, round all coefficients to the nearest hundredth. So this looks like 2 tables, but it is one table that just ran out of room. So I'm going to type all of my t's into your x values, and then all of your y's into your y values. So let's do that in the calculator. All right, so remember, you are going to press stat, enter, type in all your t's for L1, all your y's for L2. So if you've not done that, press pause so you can get caught up. After you've typed that in, you're going to press stat, go over to calc. We are going down to cubic, hitting enter a million times, and you should get the following numbers, which I've copied and pasted right here. So now I just need to take all these beautiful numbers and round them to the nearest hundredth. So I'm going to start off with y equals. My a value is negative, so negative 0. This 8 will round the 6 up to a 7, so 0.27, and my first one is x cubed, plus my b, which is 7.26. This 4 will not bump the 6 up, so just 26, x squared, minus my c, since it's negative, don't need to put plus minus, 17.62, that 0 will not bump up the 2. Apologies, I'm at my house and a bird just hit my window. Plus your last number, 1088. That 9 will bump that 5 up, so 0.86. And since that is your d value, there is no variable with that. So here is my beautiful cubic equation rounded to the nearest hundredth to represent the number of active bald eagles nests in Florida after the year 2000. We can use our model to estimate the number of bald eagles in 2018 by replacing, but I need to figure out how many years 2018 is from 2000, and that would be when your x is equal to an 18, or when your t is equal to an 18. So I'm going to plug in 18 here, and here, and here to get an answer. So after substituting 18 for all of your x values and typing it in your lovely calculator, you will get 1,549. We can't have 0.3 of a nest, so that would be my answer. 1,549 nests, bald eagle nests. Thank you, cubic regression, because we really wanted to know how many active bald eagle nests were in Florida. Thanks for watching. You can now practice, and you are done with Module 3 now. Congratulations. So good luck studying for your test.